everyone, in this video we are going to continue our lectures regarding to moment of a force using the vector formulations. Okay, in the previous lecture we have reviewed some of the concepts regarding the cross products, and in here we are going to see how the application of the cross product can be used to calculate a moment of a force. Okay, let's go ahead and consider over here that we have a plane. Okay, so I'm going to draw a plane right there. Okay, and then let's say that on that plane we have a point, a reference point O. Okay, and in addition to that we also have a force F right there. Okay, and I'm going to draw the line of actions of that force using the dashed lines right there. Okay, we also know that the position vectors, okay, between point O and any point along the line of actions of this force F is R. Okay, that position vector is R. Okay, so the moment of a force, okay, moment of a force with respect to the reference point O actually can be calculated as taking the cross product of R and F. Okay, R cross F right there. Okay, and as what we have learned right in the previous lecture, the cross product is going to give us another factor, okay, another factor that is perpendicular to the plane where those two factors are acting on, and in this case R and F are acting on the same plane, right? And then the result of the cross product, the moment itself, is going to be perpendicular to that plane. Okay, it's going to be perpendicular to that plane, and in this case I'm going to denote the factors of the moment as a factors using two arrows head right there. Okay, using two arrows head right there. Okay, and please note that factors, that moment factors right there is perpendicular to the plane where F and R are located. Okay, let's try to observe this case even further. Okay, let's say that right now we try to see this plane from the top of it. Okay, and then I'm going to draw the 2D representations of what we just drew right there. Okay, let's say that that is our reference point O. Okay, and I'm going to draw a Cartesian x and y axis right there. That's my x and that's my y. Okay, and then I'm going to draw the force F. Okay, and let's say that it has these directions over there. Okay, and then the position factors, right? The position factor is going to be right there. That is our R. Okay, that is our R. And then we have we define that unknown, right, is equals to R cross F, right? And then in the previous lectures, right? In the previous lectures, we have learned that the magnitudes, right? The magnitude of R cross F right there, right, can be calculated as, right, the magnitude of R, right, of the factor R, right, times the magnitude of the factor F, right, okay, times the sine theta, okay, times the sine theta. Okay, so this, in other words, or maybe it's better that I can write it in this way first, so it does not create any further confusions that you may have. Okay, and what is this theta? That theta is basically the angle made between the R and the F right there. it's also this theta is the same thing right there. Okay, so r f sine theta, or I can just simply write it r f sine theta, right, which is that is the magnitudes right there. And then in other words, I can just rewrite it as f r sine theta. Okay, f r sine theta. If you guys are paying attention with the terms r sine theta here, right, and if you look at the figure, the 2D figures that we draw, okay, so I'm going to extend the line of actions right there. Okay, if I can draw a perpendicular line from point O to any point along that to one point, right, along the line of actions of the force F, which is give me a perpendicular distance d, right, from point O to the line of actions right there. This d, okay, is nothing but r, which is the length of that position vectors, times sine theta. Okay, d is, so in other words right here, f, right, is equals to d, right? So in here you guys are seeing that the result of this cross product, the magnitude of the cross products over here has the same scalar definitions compared to what you have learned in the previous lectures, right, which is f times d, right, which is d is the perpendicular distance from the reference point, okay, to the line of actions of the force that we consider. Okay, and this is nothing but the same. This is the magnitude of the m naught, right, the magnitude of the m naught. Okay, so let's continue. Okay, let's continue right now, and we will talk about what we call as the principle of transmissibility. Okay, so of transmissibility right there. Okay, so what is principle of transmissibility? Okay, so I am going to consider the 2D views, right? Just kind of like redraw it maybe right here at the bottom. So that is my x, that is my y-axis, that is my O right there, right? And I'm going to extend the okay. And then we have that our force F. Okay, we have our force F right there. Okay, and then after that we have our R1, right? So R1, that is our R, right? But right now I'm going to call it R1. Okay, which is the first position vector, let's say to this point right there. Okay, and then I'm also going to define another position vectors from point O to that point right there, and I'm going to call it R2. Okay, then I'm going to call it R2. Okay, and then let's say that right now, okay, that is our that is our theta 1, right? That is theta 1, right? And then with respect to that, that is my theta 2, that is also theta 2. Okay? So my questions to you, okay, is that whether m naught, right, is it equal, it can be calculated as R1 cross F, right? Okay? It also can be calculated as R2 cross F right there. So what do you guys think about this, right? So what do you guys think about this? That m naught right there, right, can be calculated as R1 cross F. Okay, it also can be calculated as R2 cross F. Okay, and if this is valid right there, that equation is valid, those two expressions are, these three expressions are equal, how can we show that, right? How can we show that? Okay, well, perhaps if we can explain it in a graphical manner, right? Perhaps if we can explain in the graphical manner, right there, I'm going to extend, right, the line of action, right, and that line of actions, and then I'm going to kind of like draw a perpendicular distance right there, D, right, a perpendicular distance right there, D, from point O, right, to the line of actions of the force F, right, and the perpendicular distance right there, D, okay, can be calculated, right? This D right there can be calculated as either R2 sine theta 2, right, or right R1 sine theta 1. Okay, so they are basically the same, because if working on this R2 sine theta 2, we're actually looking at these triangles right there, right? Okay. On the other hand, obtaining these terms right there, we're looking at these blue triangles right there. Okay. So, in other words, these expressions right here is actually the same. Okay, because eventually, right? Eventually, as what we have shown above right there, it's going to lead us to the same expressions, right? It's going to lead us to the same expression in which, right, the magnitude of the m naughts right there will be equals to F times D when you approach it either using R1 and R2 right there. Okay, so in here, no matter which R that you are choosing, right, no matter which R that you are choosing, when you calculate the moment using this cross product, it's going to give you the same factors. Okay, that's what we call as the principle of transmissibility. So no matter what R that you're choosing right there, it's going to give you the same moment, okay, when you're calculating it using this cross product method. Okay, alright, so let's go ahead, okay, and continue the next one. Kind of like restate, okay, what we have learned from the previous lectures, and we try to bring it into the context of this moment of a force. Okay, let's say that I have a three-dimensional Cartesian systems right here. Okay, so that is my x, y, and the z axis. Okay, and then let's say that I have my point O right there. Okay, so that is my point O. Oops. Okay, that is my point O. And then let's say that I have a force F right there. Okay, and then that is the line of actions. Okay, and then let's say that I have a position factor R, okay, coming from O to any point, right? Any point along the line of actions of the force F. Okay, and then we already know, right, that the moment, right, the moment which is R cross F is perpendicular, right, to the plane in which R and F are located on, right? So in this case, if I can write my R as Rxi plus Ryj plus Rzk, right? And if I can write my F as Fxi plus Fyj plus Fzk, right, which is the x, y, and the z component of R and F right there. Okay, so we know that also that m naught, right, this can be calculated as R cross F. Okay, and this m naught, right, is going to have its x component, right, and then the y component, and then the z component. Okay, right there. Okay, in other words, right, I mean, on the other hand, we also know that R cross F, right, given that components right there, can be calculated as the determinant of ijk right there, and then Rx, Ry, Rz, Fx, Fy, Fz. Okay, I'm not going to go through this calculating this determinant again because we have done that in the previous lecture. Instead, I'm going to just write it down right there. Okay, so we will have Ry Fz minus Rz Fy I minus, right? Rx Fz minus Rz Fx J plus, okay, plus Rx Fy minus Ry Fx. Okay, so in other words, right, what we have right there, okay, this is basically our MOX right there, right? It's our MOX, right? Which is RYFZ minus FYZ, right? And then this whole things right there, that is our MOY, right? And then this whole things right there, that is our MOZ. Okay, it's our MOZ. Okay. Right. So this I can rewrite it just for clarity one more time. That MOX is RYFZ minus RZFY, and then MY is negative RXFZ minus RZFX right there, and then M not Z is RXFY minus RYFX right there. Okay. All right. I think that is pretty much what I would like to deliver for this lecture. Okay, in the next lecture, we are going to solve one example problem to enhance your understanding how to apply these factor formulations in order to calculate moment of a force. Okay, thank you for listening, and if you have any questions, please let me know.